So let's look at our oblique asymptotes. Now, if I have y equals ax squared plus b all over x, that can be written as y equals ax plus b over x. So using our previous method that we've already looked at, where we had a linear numerator and denominator, we can now read off our asymptote as being y equals ax. So that's called an oblique asymptote. So let's do an example. First of all, our denominator can't equal 0. So x can't equal 0. So that is our vertical asymptote. At x equals 0. Now let's split. We have x squared over x plus 1 over x. So that becomes x plus 1 over x. So our oblique asymptote is y equals x. Now let's look at our axial intercepts. Because we have a vertical asymptote at x equals 0, there are no y-intercepts. For our x-intercepts, we let y equal 0. So 0 is x squared plus 1 over x. 0 is x squared plus 1. Negative 1 equals x squared, and there's no solution. So therefore, there are no x-intercepts either. So let's go to our graph. First of all, let's put in our asymptote at x equals 0. Our oblique asymptote is y equals x. So pretty straightforward one to sketch. You don't need that many points. I just don't have a ruler on my computer. So I'm trying to get as many points as I can to get that line. So that's y equals x. Now, you can do what's called a sign diagram to know what's going on. If I let x equal negative 1, so I'm just looking at what happens either side. Now, you don't need to know what your actual value is. You just have to think about, if you look at your equation, y equals x squared plus 1 over x. X squared plus 1, if x is negative 1, that will always be positive. And then your denominator is negative, so that's going to give you a negative. Okay, so we know we're going to be down here for that part of my graph. If x equals 1, if we plug in, the numerator again is going to be positive, and our denominator is also going to be positive. So that is a positive, so that means we're up here. Okay, so knowing what's happening with my graph, if I plug x as 1 into it, if I actually do find out the value, 1 plus 1 is 2, 2 divided by 1 is 2, so I know that point's there. So what's happening here is we're getting a graph like that. Plug in negative 1, I get the negative 2. So your graph looks like that. Label y equals x squared plus 1 all over x. Pause the video, have a go at the next one on your own. So denominator can't equal 0, so that means x can't equal 0. So we have a vertical asymptote at x equals 0. Come back to my function and split it. So I've got 4x squared over x minus 3x over x plus 16 over x. So that becomes 4x minus 3 plus 16 over x, y equals, so my oblique asymptote is y equals 4x minus 3. So we need to be able to sketch that. So when x equals 0, y equals a -3. And when y equals 0, I have 4x equals 3, x equals 3 over 4. Let's sketch that. We have our asymptote. So I haven't put a scale on here on purpose because this ends up being quite a very thin graph if I make it to a general scale. So I've got 3 over 4 and 0, -3. So that's my oblique asymptote at y equals 4x minus 3. I also have my vertical asymptote at x equals 0. Let's think about a sign diagram. If I have x equals -1, my numerator will be positive, but my denominator will be negative. So that's negative. So I have to be down here. And if x equals 1, my numerator will be positive, my denominator is positive, so therefore I'm positive. So up there. So that means my whole entire graph needs to be above the x-axis. It doesn't cut. And then we have that down there. Label y equals 4x squared minus 3x plus 16 all over x.